So today's problem is going to be the longest repeating character replacement. You're going to be given a string S consisting of only uppercase English characters and an integer k. And I can choose up to k characters in the string and replace them with any other uppercase English character, okay? So if I have k equals 1, then I can replace at most 1 character. If I have k equals 2, I can replace at most 2 characters, and so on and so forth. After performing at most k replacements, return the length of the longest substring which contains only one distinct character. So looking at this, what is the longest substring that we can have that only contains one distinct character after replacing it k times? So since we can replace 1 time, the most efficient thing we can replace is x, right? Because y is our majority element, so of course we want to get rid of x, and then bam, we've used up our k. This would have a length of 3, right? So that's going to be our answer. But if k is 0, then it means that I can't replace anything. That would mean that our longest substring that only contains a single character would be this, right? So our output here would be 2 instead. Let's look at one more example, just so we really understand what they're asking of us. Say this is our input, right? The expected output is 5, and that's because that would be this string here, and we're going to be replacing b, turning the b into an a, which will give us a length of 5. If you slice it any other way, like here, for example, of course we can replace a to be a b, that'll give us a 4, that's also valid, but it's just not the longest one. If it's this substring, then, well, we can only replace one of the a's, so it's not valid. So that's the problem. Now how do we solve this? Like all things, we start with a loop, right? Starting with this first element here, x. So our substring so far is 1 element. So of course this is valid, and our best score so far is the length of 1. And then we go to the next element. Alright, so now we have x, y. We'll have to replace one of the elements with the other. And we can do that because we still have enough k's left over, right? So you might be thinking, which element do you replace? Well, since I don't have any other information at this point, I'm just going to replace y arbitrarily. No particular reason. We get xx. Our k goes down to 0 because we just used it up, and then we can update our best too, right? That seems pretty innocuous until we get to the third element, y. And by the time we get to y, we have xx and y, and we've run out of k elements to use, which means that this is no longer a valid substring. Now, if you zoom out a little bit, if we never committed to a substitution in the first place, we would have x, y, y, and in this case, we can choose to replace x instead of replacing y. The point I'm making is that we shouldn't permanently alter our substrings. At any given iteration, we want to be replacing all the minority elements, right? We want to figure out which element is the majority. So in this case, the majority element is y, and there are 2 of them, and the total length of the string is 3. And then must be the case that all the remaining elements that's not the majority elements are the minority elements. And since there's only one minority element, and this one is less than or equal to k, this means that this is a valid substring. If our substring looked like this, then this would not be valid anymore because y is still the majority element, the length of the substring becomes 4, and then 4 minus 2, of course, there would be 2 minority elements, and 2 is not less than equal to k, 2 is greater than k, right? So that means this wouldn't be a valid window. And if it's not a valid window, in the usual sliding window fashion, we would have to shrink the window. Let me demonstrate with a better example. So let's go with this. We're going to do a for loop, and we're going to look at our substrings, right? First loop, we'll have a. Of course, this is valid, right? In the next iteration, we'll tack on another a, still valid. So our best is 2. Tack on another a, still valid. Now our best is 3. Next element, we encounter b. And hey, look, at this point in time, a is the majority, 3 elements. Total length, and there's 1 minority element, and 1 is less than equal to k, right? Which is 1. So that means this string is valid. And you notice that I don't permanently change the structure of this. All I care about is whether this string is valid or not. I'm not actually going out and substituting the values physically in memory, right? Then we move on to the next iteration. Now we have 4 a's, the total length is now 5, still 1 minority element because 5 minus 4, and that is still within our limit, all good. What do we do here? We encounter another b. So the length of this has gone up to 6, but the value a hasn't really gone up. So what should we do? And not only that, since there are 2 non-majority elements, and 2 is greater than k, it means that this string is no longer valid. We can only perform up to 1 substitutions max. So that means we have to start shrinking. We get rid of this a. Now a is the majority, it's still 3 elements. However, our situation's pretty much gotten worse, right? I know, but we're still on. But this is still not a valid candidate. And of course, all the while, I haven't been showing it, but we do have to keep track of how many b's we have so far. And right now, we have 2, right? So let's keep shrinking. Get rid of the a goes down to 2. Now we're at 2 and 2. Oh, of course, the length is 4 now. Well, it seems to be a tie, so we'll just say 2 is the majority element here, right? We need to be replacing 2 elements, still greater than k. This will not do. And then we'll shrink one more time, getting rid of this a, shrinking our length to 3, and then a becomes 1. And now suddenly, we have a new majority element, which is b. So that means there is 3 minus 2 equals 1 minority element, which is under our limit k here. And finally, we've arrived at a valid substring. We can take the length of this. Oh, earlier I kind of forgot that when we were here, I needed to update our best to 5. And then so we can take the length of this, which is 3, and 3 is less than our best score. Unfortunately, doesn't update, but that's all right. That means that we can explore and check out other options, right? And then we get to here, we have another b. The length of this goes up to 3. The overall length becomes 4. There is 4 minus 3 equals 1 minority element, which is under our limit, right? And the nice thing about doing it this way is that let's say our strings have like, I don't know, like a C or a D or something, right? And we can have a C and a D here as well. And we don't actually have to care which element is majority and which one is non-majority. It doesn't matter for us. And the only thing we have to care about is that whenever we grow our window or shrink our window is which element is on top right now. So long as we know which is the majority element, we can figure out whether the substring is valid or not. That is all we care about. And with that, I think we're ready to jump into the code. So the first thing we do is define L and R, and this is going to determine the start and end indexes of our sliding window, right? And then next, I'm going to define a variable called counter. And this is basically just a hash map. It's going to keep track of how many times we've seen each element. And this is going to be important for us to know which element is the majority right now. And next up, we need a variable keeping track of the majority count, right? We don't care exactly which element is the majority. All we care about is how many instances of the majority elements are there. And then it's just going to be the result that we're going to return at the end, right? Next up, just the while loop for our R. Now we've encountered a new element. We're going to add that element into our window. Since that element is now part of our window, we need to increase its value in the counter. So let's take this example right now. Our counter right now is x1, and yeah, that's it so far. And since we've just added a new element, there's a possibility that the majority element has shifted. So of course, since we've just started, we're not tracking any majority elements right now. So automatically, this one here is going to be our majority count. I'm going to say k equals 1 for now. And now we need to check whether our current window is valid or not. And to check that, we need to take this, r minus l plus 1. This is going to be the length of our current window. Our current window is just x right now, and the length of that is 1. It's going to be 1 minus the majority count, which is 1, to get the non-majority count, which is 0, right? So that's saying that our current window or substring right now is made up completely of the majority element, which is true. It's only 1 element long. So because of that, we don't have to shrink. Now that we know for sure that our window is valid, we can take the length of that window and update our result if it's better. And of course, we need to iterate r by +1. And by the time we finish, we have to return result, right? So let's keep going. Let's see what happens in the second iteration. So now we add this y to our counter, and then we'll update our majority count if there's an upset, but there isn't because the new value is the same, it's just 1. And now we're going to execute the while loop where we'll shrink the window until it's valid. So the length of the current window is 2, and the majority count is 1, right? Either x or y. So we have to replace one element, and that's all right. Our k can handle it because this will be 2 minus 1, which is 1. And 1 is not greater than 1, okay? So that's fine. And then we do the rest of this, and then we'll just update our result. And then in the next loop, it'll be another y. The y comes in, updates this value to 2. And now y is greater than x, right? So now we have a new majority count. That's going to be updated to 2. And then when we run this check, it'll be 3 minus 2, which will still give us 1. So that means we don't have to shrink anything. Our window is still valid. And then final iteration, when we get to this last x, things will be different. This line is going to update x to 2. Well, the majority count is not going to change. The length now is 4, right? We have x, y, y, x. Our window is basically the whole string now. It's going to be 4 minus 2, which is our majority element, which will give us 2. And 2 is greater than 1. And now we have to shrink. The shrinking is pretty convenient. All this time, we have a pointer pointing at the first element this whole time. So we can start popping. We'll reduce the counter of this x here. So now this x will go down to 1. Just like the example we've seen in the blackboard earlier, when we shrink the window, there's a possibility the majority count will change, right? Which is why we have to do another check here to update the majority count if the hierarchy changes. And then we'll simply increment L. So now this x is gone. Bye-bye. And now this is going to be a valid string because we'll take 3 minus the majority count, 2 will give us 1, and 1 is not greater than k. And then we can execute the rest of this code. And that's about it. This should give us our answer. And there you go. Let's talk about time and space complexity. The time complexity is going to be O of n because our R pointer is going to be mindlessly incrementing each value, and then our L pointer, in the worst case, might also go through every single value in the list as we shrink. And every other computation that we have in our algorithm is O of 1. So we can see that the time complexity is O of n. As for the space complexity, the only extra space worth considering is this counter here, and the size could potentially grow to the number of unique characters in S. So in the worst case, that's going to be n, which is why the space complexity is O of n as well. And that's about it. Thanks for watching. Okay, bye.